So last year, I came here and I gave a talk about the lessons that we had learned over the last 2-3 decades, of which I was involved in the last few years, building web and internet protocols like TLS. To be honest, a lot of this inspiration for trying to fix these protocols over the last few years came from the Snowden revelations, when we realized that having a broken encryption protocol for every single website was actually a vast source of abuse, a vector of attack. But thanks to conversations with Amir and all my other friends here and the inspirational time I had, I decided to leave my job as a researcher at INRIA and decided that we were going to follow the herd, man. We're going to do a blockchain startup. And I sat down and I said, well, what is it if we could redesign the internet? If we could we build in privacy from the ground up? And could we make it a system flexible enough that we could provide not just privacy on the blockchain, because to be honest, there's tons of teams doing that and most of them are doing a pretty good job, but could we get privacy on the entire system as a holistic system? And that's what we're unveiling today. This is the first public talk on NIM technologies, and we're building the next generation of privacy infrastructure. So the goal is not our particular technology stack per se, although we hope you learn about it, but I also want you to think very seriously about privacy and whatever you're building, and we need to come together as a community in order to end mass surveillance, try to make it technically impossible, not just legally difficult, because obviously that's not worked very well for the last few years. Snowden's still in Russia. And we also need to be aware of the new threats to privacy that are coming up, that are now possibly even emanating from the blockchain space, like the Libra. So let's return to our roots. The Cyberpunk Vision, I'm just going to quote Eric Hughes here, from 1993, pointed out that privacy is necessary for an open society in the electronic age. But privacy isn't secrecy. A private matter isn't something one doesn't want the whole world to know about, but it's simply a secret matter that one doesn't want everyone to know. Privacy is the power to selectively disclose oneself to the world. And that's very important. Otherwise, we become part of a totalitarian system where structures beyond our control who we are and what we can do with our destiny. And that is the elimination of human freedom itself. And I do not think that technology has to destroy human freedom. I support what Richard Stallman believed and what he explained earlier, that we can build other kinds of technology that support and are even necessary for human freedom. But the very architecture of the internet, as I explained last year, prevents privacy. People weren't thinking about it. The original internet was unencrypted, and even when you add on encryption, you leak metadata, as David Chaum so eloquently put. And we have some solutions today. I think Tor, this is from the NSA revelations from Edward Snowden. And you can see the NSA was looking at Tor. And they had a program to break it. We'll talk about that in 1 second. But I think the most important thing to remember is that as of 2013, the NSA was actively attacking Tor. And that's the best we have today. The amazing thing is 20 years on from the founding of Tor, the turn of the millennium, it's still the best we have. And what is Tor? Well, it's an onion router. It enables, anonymous might be a strong word, but it hides your geographical location via hiding and obfuscating your IP. And as put by the NSA, it has hundreds of thousands of users, currently 6,000, 8,000 nodes. It supports dissidents in places like Iran and China, maybe some people the NSA doesn't like as well, and other targets too. But there's an egotistical draft didn't actually try to break the sort of design of Tor, which was funded by the US Navy and the US government. Instead, it went after a kind of minor crypto problem in the Tor browser and did break it, and they fixed the Tor browser. But there's a larger problem with Tor. Tor does indeed leak metadata. Okay, it's better than a VPN, because with a VPN, you're just putting your root of trust in the VPN provider, which is someone you don't even know. At least with Tor, you put your trust in a crowd, a peer-to-peer network. But fact of the matter is, traffic going into Tor and out of Tor can be de-anonymized by what's called in cryptography a global passive adversary that can watch the entire Tor network, or at least the entry and exit nodes. And that seemed unrealistic in 2000. But after the Snowden revelations, we understand that the power of the NSA is such that they can watch all the Tor entry and exit nodes. And academic research by George Denises at Microsoft Research, Carmelo Troncoso, now at EPFL, has shown that traffic analysis is very effective at de-anonymizing Tor users. And we have to build something better than that. And this isn't just a Tor problem. It's a problem with the entire internet. And it's also a problem with cryptocurrency. So it doesn't really matter what you put on chain if your peer-to-peer broadcast can reveal your IP and can de-anonymize you. So Bitcoin is completely vulnerable to this. Even with Dandelion++, which is essentially a peer-to-peer equivalent of a VPN, you can just, if you're watching the whole network, you can de-anonymize that entire path. Ethereum, of course, has this problem. Privacy-enhancing technologies and coins, Monero, Grin, Zcash have this issue. They've tried to deploy solutions like I2P with kind of mixed results. And if you read the Zcash paper, the Zcash paper, like most cryptography papers, says we're going to assume an anonymous communication channel. That's a pretty big assumption because we don't have one right now. And this is a day-to-day problem. Every time you use Signal, Signal is end-to-end encrypted, but an adversary that's watching the Signal server can see the timing of when messages go in and out and can use that not to break the encryption and reveal what you're saying, but who's talking to who, where, and when. And don't even think about the rest of the internet, because every time you install an app or you log in with Facebook, log in with Google, you're basically, every time you do that, your entire pattern of which services you're accessing when and where gets revealed to a few centralized identity providers that currently control the identity system of a third of humanity that's larger than any nation state and much bigger than Bitcoin. So again, the problem on an abstract level is, if you want to have a privacy-enhanced blockchain, which I think we do, at least a side chain, let's say, your metadata is constantly exposed to the network, and you have to defend layer 0, the peer-to-peer, or just in general internet network level privacy, the TCP/IP UDP level. And furthermore, Tor is built, to be very honest, before Bitcoin. Experiments like Mojo Nation had failed, and incentive structures were viewed negatively by the cypherpunk community as a way to really build real software at the time. But at the same point, now we know with Bitcoin and Ethereum that incentive structures do work. And furthermore, no one really saw the fact that usernames and passwords would effectively be replaced by centralized identity providers that can not only capture and sell your data without your knowledge, because everyone just clicks through the terms of service, but also they can modify and censor your transactions. We do not have, it's completely crazy. People want to build a decentralized financial system that's censorship resistant, but we don't have a decentralized, censorship resistant, and privacy enhanced network level. So that's exactly what we're building. We want to end metadata leakage by building layer 0 privacy that can be used by any application. We want credentials that allow people to authenticate and transfer any information to, across this network privately under user control. And we want to incentivize this network in a similar way that Bitcoin uses mining to effectively say, hey, thanks for mining. I'm going to reward you for doing this useful activity. The fact that mining is maybe solving Merkle puzzles isn't that useful. But, mixing traffic, proof of mixing rather than proof of work, is a computation which is expensive but helps ordinary users defend their privacy. So if I'm going to put a server on the internet and run a full node, I want that server to be cranking out computation which helps everyone have privacy. And so I'm going to go through each of the bits real quickly. So mixed nets were invented by David Chaum in the 80s. It's an honor to even share the same stage with him. And I'll just give a quick explanation. Our system is a little bit different than his. I think if you're using Elixir, you don't really need our system, but every other system needs our system. It works differently insofar that we use timing obfuscation. So a classical way of thinking about mixing is you get packets in, you wait to get enough packets, and you shuffle them, and then you push them out. That's a batch mix. However, what we do is a bit different. We do timing obfuscation. We basically delay packets, so there's a constant distribution of packets going in the network and out the network. And that solves the problem that Tor has with the NSA, and that Bitcoin has with chain analysis. Effectively, if traffic comes in and it comes out, and the timing is obfuscated, it disrupts the pattern in the traffic. But let's say you don't have enough traffic. Well, we create decoy traffic, fake traffic, which prevents the pattern from being detected. And this timing obfuscation and decoy traffic with a loop back to make sure you got your traffic is effectively, we think, a scalable and probabilistic way to guarantee fast and NSA-resistant metadata traffic. And that's great. And the fact of the matter is the system also has multiple hops. So you unlink at every hop, and it's scalable. The more users that join, you just add more nodes in. And we can build huge anonymity sets. So I just want to give, I don't know if he's here, I want to give a shout out for David Chaum, if he's here, for inventing all of this technology in the 80s. We're on the shoulders of giants. But the fact of the matter is, we have to build this ourselves. We can't rely, we can't rely on anyone else to do this. And so we're going to basically show you how it works. How it works is users basically download a library. And in that library, they can convert their packets to what's called the Sphinx network packet format, which is used by Lightning. It's an encrypted packet format which makes every packet the same size and hides the next hop. It's provably secure. It's been around for 20 years almost. Once the packet is encrypted, it goes into the network and goes through at least 3 hops. And if we have more traffic, we extend rows in the network. And if we don't have enough traffic, we add in that dummy traffic. And then at each hop, there's timing obfuscation added, which disrupts the pattern in the traffic. And at the end, the packets are anonymized, and they can access a service. Whatever that service is, it's generic. We don't care, but we can imagine all sorts. And this is similar to Tor in the fact that there is at least 3 hops. There's not a centralized root of trust, unlike VPNs. But again, the main difference is it's better than Tor because we defeat traffic analysis. And I have a lot of respect for Roger, but I think the Tor people would agree for message-based systems where you're accessing services where you want to defeat traffic analysis, Tor is not the way to go. Mixed nets are the way to go. And the fact of the matter is, of course, when you add privacy, you're adding mixing and shipping traffic to multiple nodes. It does affect latency. But what this graph explains is that you can actually customize your network. You can fine-tune it so that you can get high latency with a little bit more privacy. So, for example, for Bitcoin traffic. But if you want to speed things up, you can get lower latency and sacrifice a bit of privacy. And if you add more capacity, if you add more nodes, you can get better privacy and lower latency. And that's the sweet spot where we think most applications want to end up. And it's very important to remember that, the more people that use the network, anonymity loves company. The more people that use the network, the larger the anonymity set becomes. And the less dummy traffic we have to produce. Because why produce dummy traffic when you could produce real traffic? And now, of course, the issue is, well, if you just open a mixnet to the world, what prevents, every spammer and crazy person in the world from just doing a massive Sybil attack on you? Okay, and that's actually Adam Back, who's now the CEO of Blockstream and an old school cypherpunk. He used to run a mixed node. Mixnets did exist, like Mixminion and Mixmaster, for anonymizing email. And when he was getting so much spam, and he's like, oh, maybe we should do this proof of work thing, Hashcash. So originally, Hashcash was invented in order to basically prevent Sybil attacks on mix-based anonymous cypherpunk email remailers. And we've said, well, why don't we do the same thing? But let's not do, like I said, let's not do proof of work. Let's just simply have a credential where people can ship through packets, and they go to services. And those services can then determine what data they need for operations. And we can use these packets to embed anything from cryptocurrency to fees to whatever, and we can use that to help incentivize the network. And what we need is, again, we return to David Chaum's work, where he built this thing called blind signatures for anonymous eCash, called Chaumian eCash. And the latest version of the system was mentioned by Richard Stallman, called GNU Taler. But the problem with all of these systems, based on kind of like some sort of anonymous credential system, where you can get in, and you can basically send through payment or any kind of personal data you want. The problem with these systems is that even if they're privacy preserving, they're centralized. And that's historically been the issue with anonymous authentication credentials. But luckily, there was a breakthrough that happened due to research, mostly the work of George Denises, Mustafa, if he's here still, Alberto, Shehar, and this is called the Coconut Credential Scheme. And what it allows is it allows decentralized anonymous authentication credentials. And that's amazing, because what that means is that you don't have a single root of trust. Like when you log into, like, say, Facebook Connect, Facebook knows that you're logging in. Or if you want to, you could basically log in, authenticate, transfer any data you want, and you could just use a threshold signature. So you don't have a centralized root of trust, only X of Y, 2 of 3, 6 of 10, whatever, in order to basically authenticate. These transactions are anonymous because we use re-randomizable cryptography. So at each hop, the ciphertext itself can be re-randomized. And it's selective disclosure. You can put in these credentials anything you want. And it basically, for public data, you can embed it directly. For private data, you embed zero-knowledge proofs that you know this attribute. And you can use these zero-knowledge proofs in order to build pseudonymous integrations. You can build pseudonymous accounts that you unlink later. But for anyone observing the network, they can't link your usage of the network. And it's a very complex scheme. I won't have time to explain it all today, but you can imagine, I'll just give a quick run through. A user agent basically gets some personal data. Maybe they want to access, let's pretend we want to access like an anonymous decentralized signal. So basically we embed our contacts. Maybe we're paying for a monthly subscription. We embed some payment. We take the payment out of like an ERC20 compliant blockchain. We wrap it all up. We basically give it to some validators in an encrypted fashion. So the validators don't know what's in the credential. The validators say, yep, it's a valid credential for the service. They give us back an encrypted ciphertext. In step 3, re-randomize the ciphertext, so it's unlinkable to what the validators saw, and we put it into the mixnet. And that mixnet basically erases the metadata, the timing information of that credential, and ships that credential to a service provider, such as, for example, our anonymous, decentralized, private version of Signal, and they open it up, and they say, oh, yes, this is indeed my new pseudonymous decentralized Signal account. That's great. Even Signal itself couldn't link that usage back to you because the mixnet, again, removed metadata, and all the data going to this decentralized Signal is under your control. So, if you want to reveal who you are, you can, but you don't have to. And all that a decentralized version of Signal has to do is then check with the validator. to make sure it's a correctly formed credential. And then, if they want payment at the end of the epoch, they get paid. And we have a small Tendermint-based blockchain on the side to prevent double spending attacks and to help keep track of the operations and the PKI of the mixnet, which no one else has done yet. It's really fast, performs at scale, less than a second. And this thanks to Andrew, who's out there, who's been working really hard on this for a year, coding it up. And lastly, the problem with this entire network, it sounds great, but we need to incentivize people to join it. We basically need, just like people, in their college dorm would have a machine, and they turn it on, they start mining Bitcoin, being part of the Bitcoin ecosystem. And they did the same thing with Ethereum. We want people to do this for our infrastructure, for mixed nodes, so that it no longer becomes our infrastructure, but becomes decentralized to the entire world. And so we're just going to do a proof of stake scheme based on Ouroboros, probably. But we're adding rules because, for example, we want a geographically dispersed global network. Tor, to be honest, it's mostly Americans using Tor, being shipped to German Tor nodes and shipped back to Silicon Valley services in America. And we would like to make sure that this network has access and speed anywhere in the world with high quality of service. So again, we do this by, and thanks a lot to Jeff Burgess and Fatima and everyone else at Web3 who are actively working with us on fair rewards via VRFs and Merkle tree commitments. If you want to have a fee, we can take fees, but we don't have to. Depends on the service you're using. And the tokens are deflationary. So essentially, that's the mixed nodes and other parts of the infrastructure are rewarded for coming in early. And I think, that's nothing more than Bitcoin mining, but mixing rather than mining. And we know that works. And there's tons of use cases, not just a decentralized signal. We want to increase the privacy enhancement of any cryptocurrency. We've been talking to Zcash, Monero, Ethereum, Bitcoin. Again, generic, we don't care. We do think there's some use cases that make a privacy-enhanced decentralized VPN with a high quality of service. And we can use the credential system to basically build private authentication for passwordless login and sharing of personal information under user control for any system. And to return to the decentralized privacy-enhanced messaging, we're actively working with Status, who's also here somewhere, and Web3 Foundation to make this a reality. But there's new threats. There's new problems. So one of our co-founders, George Denisis, we get dinner, he's like, I'm working with this other startup, Chainspace, and we just got bought. And I congratulated him. He said, but you'll never guess the company. And indeed, they were acquired by Facebook. And a few months later, out came the Libra. And a lot of people ask, why isn't the Libra privacy enhanced? Well, to be very honest, Zcash and do the nullifier set and whatnot, these kinds of technologies are very hard to audit and hard to scale. But what Facebook is really doing, if you look closely, is they're not using privacy-enhancing technologies, but saying, oh, don't worry, we'll have a pseudonymous blockchain. But the on-ramp into that pseudonymous blockchain is the Calibra wallet. And if you read carefully the statements they made about the Calibra wallet, in order to, under the guise of complying with various regulations, which they kind of have to do, they will going to leverage the tremendous amount of personal data they have in order to basically make sure they know who's using the Calibra wallet. And that's incredibly dangerous because all of a sudden we've entered a space where we might kill innovation in the blockchain space and fragment the blockchain into the whole space, into two different spaces. One space where we still try to maintain pseudonymous keys, where we still try to fight for user privacy, in another space where we've basically fallen into the same totalitarian identity system, which we're just seeing the beginning of with Facebook Connect. But we do think there's a way out. Again, the technology we presented, mixed networking on level 0 and credentials, work with any blockchain. It's not yet another blockchain, it's not yet another cryptocurrency, it's a generic set of techniques. And these credentials can effectively help create privacy-enhanced versions of any, as side chains of any chain, and that may even work with Libra. Even if Libra takes off, we still have a chance to build privacy-enhanced side chains. And I think that might be the way out. That might be the way that David beats Goliath. And the thing with David versus Goliath is David wins. So this is our team. Some of them are around. Say hello to them. We're all here, minus Anya, who's presenting mixed nets at Usenex. And if you want papers, we've been working on this, funded by the European Commission, Panoramics, Next Leap Decode, $12 million in total of European Commission funding, the same funding that created ChainSpace, which was acquired by Facebook. And the papers are open source and public, and we would love for people to jump on board, help contribute new research, contribute new code, and we're going to demo the Coconut-enabled NIM credential tomorrow at ETH Berlin. So I just want to end by saying it seems impossible. It seems like we're in an internet of mass surveillance where there's no way out. But actually, we know there's a way out. Technology, just because you work in technology does not mean you're a techno-determinist. The way to think about technology is it's a force multiplier. It can multiply the individual force of individuals collectively bind together and change the world. And so I consider technology as a lever. And as Archimedes said, if you give me a lever and a firm place to stand, I can move the earth itself. And I think that's what we have to do to fight for our freedom and privacy on the internet. And we will need a social movement empowered by privacy-enhancing technologies. Otherwise, everyone will be identified, classified, and if viewed as a possible threat to the reigning order, surveilled, imprisoned, and even killed. And we can prevent that from happening. But what we need is not just technology, we need a social movement. And I consider the programmers in this room to be the core of that social movement. We are the alternative to Google and Facebook. We can bring the ideals of Richard Stallman and David Chaum to life, and we can build an alternative internet, a Web 3.0. And that requires exactly what we're doing here, getting together, organizing, programming, building. So I just want to end by saying, I love the technology, but ultimately, the future will come down to people, and all power to the people.